Hello everyone! In this guide I want to show you something that took me a long time to figure out while creating my first game in Miliastra Wonderland. A roguelike-style, randomized deck selector with level caps. Let me explain how it works. When you interact with a chest, a deck selector appears with 3 choices. At first glance, it looks like any other deck selector, but it has 2 key features. First, the 3 options are randomly chosen from a pool of 8. Second, each time you select an option, it levels up. As you play, you can encounter many of these chests, allowing you to keep upgrading your choices. Once any option reaches its maximum level, it will no longer appear in the deck selector for the rest of the game. In my game, weapons have a maximum level of 9 and boons have a maximum level of 5. As you can see, after upgrading the movement speed tonic to level 5, it no longer appears on future deck selectors. This should be pretty useful for anyone looking to create a roguelike game with lots of different upgrades to collect. Now, let me show you how to create it step by step. Before we go into the node graph, there are a few preliminary steps we need to take. First, we need to create our deck selector with all available upgrades in the pool. To do that, head to Manage UI Control Groups tab, then click UI Control Group Library and select Add UI Control Template, Deck Selector. Next, click the small arrow on the left and select Panel. In the Page Settings tab, you adjust your deck selector settings, such as the title or layout. You can also choose whether to show the selected quantity, reset count limit, or remaining time. If you're making a roguelike game, you'll probably want to leave the Selection can be cancelled option unchecked, unless you want players to be able to skip upgrades. If you enable Controls can collapse, the deck selector can be manually collapsed, allowing upgrade choices to be delayed or timed out. After adjusting the options in Page Settings tab, move to the second tab, Option Configuration. Here, you can configure both known deck settings and unknown deck settings. Since we'll be working with a known deck, only the display options are relevant here. You can hide the deck's icon, title and description, but I would recommend keeping them visible. The most important setting here is the deck list, because this is where your full upgrade pool is stored. Click Edit Details, then for each option, click New Row and fill in the deck icon, title, description, and optionally the tag color. My game has 8 upgrades in total, so my deck list contains 8 different entries. Make sure the deck type is set to known deck. After you finish, save your new deck selector by clicking Save as Template and copy its index, since you'll need it later in the node graph section. Next, we need to add some custom variables. Their purpose is to track the level of each upgrade, set the appropriate weights for the weighted random node in the node graph, and determine which upgrades appear in each slot. To do this, go to the fourth tab, Combat Preset. On the right side, click Edit Player, then open the second tab and click Advanced Editing under Custom Variable. For each upgrade option, you will need 2 separate custom variables, one to track its level and another to set and reset its weight for the weighted random node in the node graph. In addition, you will need 1 custom variable for each slot in your deck selector. In my case, I have 8 upgrade options, so I need 8 custom variables to track upgrade levels, 8 custom variables to set and reset weights, 3 custom variables for the 3 slots in the deck selector, since it chooses 3 out of the 8 available options. You can add custom variables by clicking the plus Add New Variables button. Make sure to set the type of all these variables to integer. Now it's finally time to open the Beyond editor and create a new node graph under Server Node Graph by right-clicking on an empty space. This may look a little daunting at first, but once you understand the logic behind it, it's actually quite simple. Start by creating the When Tab is Selected event node, since this node graph will be mounted on a chest. Then create a getPlayerEntity to which the character belongs node nearby and connect it to Selector entity. The affiliated player entity output should then be connected to every target entity pin, because we want to check and modify the custom variables of the player interacting with the chest. The first part is the level checking section, which is tied to setting the appropriate weights for the weighted random node later. We need to check whether the player already has any upgrades at their maximum level. If they do, we set the corresponding weight to 0, so that option can no longer appear in the deck selector. To do this, enter the custom variable's name in a getCustomVariable node, then connect variable value to left value in a greater than or equal to node, and enter the maximum level of the corresponding upgrade. As I mentioned earlier, in my case that's 9 for weapons and 5 for boons. Next, connect result to condition in a double branch node. Then create two setCustomVariable nodes for that weight. If the player already has the corresponding upgrade maxed out, the double branch result will be yes, and that weight should be set to 0. Otherwise, set the weight to 1. Repeat this process for every upgrade you have. The next part is assembling the list of weights. At this point, each weight should already be set to either 0 or 1, so connect them to an assembly list node by linking variable value from each getCustomVariable node to the number inputs in assembly list. Make sure the data type is set to integer. Then connect the assembly list output to the weighted random node and connect weight ID to control expression in a multiple branches node. This causes one random option to be selected from all currently available upgrades. For each upgrade option, there should be one connection from multiple branches to a setCustomVariable node. In my case, that means 8 separate connections. This next part determines which upgrade appears in the first slot of our deck selector. To do this, create a setCustomVariable node for every upgrade in your pool. Then set the variable value from 1 up to the last number in the pool, which in my case is 8. The variable name should always stay the same and should match the custom variable you created earlier for that slot. The variable value is tied to the upgrades order in the deck selector. In my case, 1 means sort, 2 means explosives, and so on. The next set of setCustomVariable nodes should reset the weight of the selected upgrade to 0, since we don't want duplicates appearing in the other slots of the deck selector. Then, simply repeat the same process for each remaining slot in your deck selector. In my case, I repeated 2 more times. The only difference is that the variable name in setCustomVariable should now use the variable assigned to slot 2 and slot 3 respectively. Finally, you need to assemble a list of your slot variables by connecting variable value from each getCustomVariable node to an assembly list node. Then connect list to select result corresponding list, select display corresponding list, and default return selection in invoke deck selector. Next, paste in the deck selector index and set the duration of the deck selector. Then choose the minimum and maximum number of upgrades the player can select at once and set the refresh quantity. At the end, you will probably want to destroy the chest after it has been opened, so connect invoke deck selector to a destroy entity node. This time the target entity should come from event source entity in the when tab is selected node, not from get player entity to which the character belongs, because we want to destroy the chest, not the player. Let me also show you how it looks in the log. You can enable logging in Windows Log, and then select the node graph you want to check. As you can see, at the beginning, all weights are set to 1 because the player doesn't have any upgrades yet. The weighted random node chose 5, which means the 6th upgrade since counting starts from 0. That means the 6th upgrade was chosen for slot 1, and then its weight was set to 0. Next, the second weighted random node chose 6, which corresponds to the 7th upgrade in slot 2. Notice that it couldn't pick the 6th upgrade again since its weight has already been reset. Then, with only 6 options left, the final weighted random node chose 7, which is the 8th upgrade for the slot 3. In the end, the final assembly list for our deck selector shows the output list as 6, 7, 8, which is exactly what we saw when I opened the chest. Finally, the chest was destroyed by the Destroy Entity node. After finishing this node graph, you also need to make sure that the chosen upgrades increase their corresponding upgrade levels. You can do that by creating a simple node graph mounted on player entity, not on a chest this time. Again, head to the Beyond editor and create a new node graph. This time, the main event node is when deck selector is complete. First, check that the selector index is correct by copying and pasting the selector's index into an equal node connected to deck selector index. Then connect the result to condition in a double branch node. This ensures that the node graph only reacts to the specific deck selector you want. Then use an enumerations equal node. Connect enumeration 1 to completion reason and set enumeration 2 to completed by player. Connect the result to another double branch node. Finally, create a multiple branches node with as many connections as you have upgrades and use ID 0 from get corresponding value from list as the control expression with that node connected to selection result list. In each branch, use the same 3 nodes: set custom variable, get custom variable, and addition. The target player should come directly from when deck selector is complete. As before, the order must match the one in your deck selector under Manage UI control groups. In my case, 1 is sword, 2 is explosives, and so on. Each time an upgrade is selected, we want to add 1 to its corresponding variable so its level increases correctly. And that's it. I hope you found this guide helpful, and I hope this roguelike style randomized deck selector with level caps gives you some ideas for creating interesting games in Miliastra Wonderland. Thanks for watching.